Okay, in this video, we're going to go over simplifying radicals. So when you simplify radicals, in this case, specifically square roots, what you want to do is you want to break down the radical to have the smallest number underneath the radical, or the radicand, as possible. Now, in the first example here, the square root of 9, the square root of 9 happens to be a perfect square, and it's 3. So you don't have to do this simplifying process we're about to do. However, the square root of 48 is not a perfect square. Therefore, we have to approach it in a different way. The square root of 48 as an approximate answer is 6.928. However, this is not what it means to simplify. Simplify means we're not going to have decimals. You would use 6.928 if you had the word evaluate. But to simplify, what we need to do is we need to break it down. So we'll look for the biggest perfect square that goes into 48. So some perfect squares are 1, which is never helpful for radicals, 4, 9, 16, 25, 36. And there's no point in checking any higher ones. I think the biggest one that goes into it may very well be 16. If I remember right, it's 16 times 3. So we'll rewrite the square root of 48 as 16, the perfect square I'm choosing, times 3. One of the properties of radicals says that if we have two things multiplied inside the radical, we can separate it into two separate radicals. So we'll separate the square root of 16 times the square root of 3, or times 3, into two separate radicals, square root of 16 times the square root of 3. And then we can actually evaluate the square root of 16. Square root of 16 is 4. We can't actually evaluate, or we could evaluate it, we just can't have an exact answer. So we'll leave it as the square root of 3. So simplifying, you will never have a decimal when you are simplifying a radical. What you want to do is you want to break it down so you have the smallest number possible on the inside. For the third one, we're going to do the same thing. You'll notice that it does have a coefficient, but the idea behind it is the same, that 5 is connected by multiplication. So when we go to separate, we'll have to keep that in mind. But we're going to focus on the radical first. What's the biggest perfect square that goes into 24? The answer to that is 4. 4 times 6 is what 24 will be broken into. We also have our 5 out in front. According to the property with radicals, if we have two things multiplied underneath, we can write it as two separate radicals. So the square root of 4 times the square root of 6. Square root of 4 here is 2, so we can write it as 5 times 2 times, well, the square root of 6 is not a perfect square, so when it comes to simplifying the expression, we will leave it as the square root of 6. And then just multiply what we can back together. 5 times 2 is 10, radical 6. There we have it.